Okay, so I want to look at, let's start with question 3. I want to look at just some angle relationships that we need to know. So what type of angles, or what are the names of the relationships that we have? What are the names of the relationships that we have in angles? No, you're right. You're right. I'm sorry. I'm trying to move my screen here a little bit to make it easier. You're right. So we have alternate exterior angles, alternate interior angles, consecutive interior angles, and corresponding. Okay, so you have to know what each of these are and the relationships. Oh, we also have vertical angles. That's another one. Okay. All right. So if angle here on number 3, it says the measure of angle 7, find it if we know the measure of angle 4 and the measure of angle 6. Okay, well, here's angle 4 and here's angle 6. So what's their relationship? What kind of angles are they? Okay, these are the consecutive interior angles. All right. So what do you know about consecutive interior? All right. So they equal 180. Perfect. So we're just breaking down what we know. But it said that we need to find the measure of angle 7. So do we have a relationship between angle 7 and angle 4, or a relationship between angle 7 and 6 that would be helpful? 7 and 6? What are angle 7 and 6? Diagonal is not one of the names that we have. They're vertical.
Okay, wait, no, that's what I was so confused about. Isn't that like more diagonal than vertical?
It doesn't matter. These are vertical angles. That says vertical AL. So it is more diagonal than vertical, but vertical angles are created when any two lines intersect. So like the blue circles are vertical and the red these would be vertical from each other. Okay, so when any two lines intersect, they create vertical angles. And what do you know about vertical angles? They're equal. They're congruent is the word that we would use. Okay. So we have to know, that's the thing about geometry, is we have to like look at it and be like, okay, well, what do we know first? Like, what do we know from there? What do we know from there? What do we know now? Okay, so if we know that these are consecutive, 4 and 6, and they gave us the measure of 4, and they gave us the measure of 6, but we know these two things together equal 180, what should we do? They equal 180 when we do what with them? When we add them. So we should say like, hey, x plus 6 plus 4x minus 1, I'm going to put that in parentheses, that's the other quantity, equals 180. Okay, then I can go back and look at some other things. I can solve for x, and then I can find, once I know it, I can find 6, the measure of angle 6. Then I can also know the measure of angle 7. So it's like this roundabout way we have to go to solve everything. Okay, does that give you a starting point to making any corrections you would need on that one? Did you write that down?
So it's the angle 4 plus angle 6 equals 180.
All right, so let's look at this number 6, this proof. Okay, again, proof is like we're following logic here. All right. How many of you drew a picture to help you with number 4?
I didn't because the picture's already up there.
Okay, so I used the picture above too, like it kind of worked. I didn't draw one. So good for you to notice that. So we can use this picture above. It has 2 transversals. No, it doesn't. Yeah, it has a transversal, which we don't need. But it could still work. Yeah, actually, we do need it. Never mind. We do need the transversal. All right, so we've got this idea. We know we are given that M is parallel to N. Okay. We're trying to prove that angle 2 is congruent to angle 7. Okay, so I'm going to mark those. I'm trying to get there. Okay, they're telling me angle 2 is congruent to angle 6. That's what they said here. All right, well, what is their relationship? Angle 2 and angle 6 are what type of angles?
Oh, they're corresponding.
Angle 2 and angle 6 are corresponding angles. Okay, so these are corresponding angles. So I'm going to use a lot of shorthand. Okay. That is not the answer for number 2. Okay. Are you sure? Let me rephrase. Are you sure?
Corresponding angle postulate.
Okay, so what is the corresponding angle postulate say? Get out your sheet. What does the corresponding angle postulate say?
If two parallel lines are cut by transversal, then corresponding angles are.
Okay, I love that. It says if two parallel lines. Look at this. They told us the parallel line that they were two parallel lines, didn't they? So they gave us the if. The statement, the information in the statement that's preceding, that comes first, is giving us the if for the next one. So if we have two parallel lines, then the corresponding angles, which we said they are congruent. So yes, this is the corresponding angles postulate. Okay. Now, so for the next one, all the information we have in 1 and 2 is the if for 3. So if we have parallel lines, and if angle 2 is congruent to angle 6, what does the vertical angle theorem tell us? Read me. Okay, but read me the read me the vertical angle theorem. What does it tell us?
Vertical angles are.
It says vertical angles are congruent. So we already picked out a set of vertical angles, right? We said 6 and 7 were vertical. So now we know they're vertical, but now what do we know about them because we know they're vertical? They're congruent. So we could say angle 6 is congruent to angle 7 because of that vertical angle theorem. We know that. All right, so now we're building on that. We're going a step further. Okay, so now we know all of this. And they said, well, hey, angle 2 is congruent to angle 7. Well, how do we know that? Alternate exterior angles are congruent. I could take that one potentially, but then this one would have been, step 3 would have been wasted at that point. Can you give me a different one that goes that way? Because this is 2 and 3 are key here because we said, well, hey, angle 2 is congruent to angle 6. Angle 6 is congruent to angle 7. So angle 2 is congruent to angle 7. Oh, there's an aha moment. Nice, you're looking. It's not in a theorem. It's not in a postulate. It's not a definition. It's a property. Yep, it's one of the properties. You're looking in the right place. What property is that? Don't listen to him. Say it.
Is it the transitive?
It is the transitive property, right? Because if we have that same thing in the middle, right, then it like takes out. Like we can just transfer it. So this is that transitive property. Yes, like you could have used alternate exterior angle in a different way, but not in this one, not the way that they did it. Which is why sometimes it's actually nicer, like the fill in the blank postulates can be helpful, but it means you have to go in like the train of thinking that they're giving you. Where like sometimes I think about problems differently and I would have maybe solved it differently. So, but does that make sense? Like how we're looking at it? So we're going to go through that last one as well that we have.
See, that's why I feel like number 4 should be still counted correctly because I put alternate exterior.
Again, it's the train of thinking here. I'm sorry.
I'm built different.
You are built different. Okay. Okay. Again, let's see on the back of that sheet. All right, so let's look at 7.
Is that A is parallel to C?
Oh, up here, 6b. Yeah, so let's look at 6b. And we can, again, because we're trying to use that logic, okay? So if A is perpendicular to B, let's think about the slope of A. Let's just give it a slope. Give me a slope for A.
2/4.
Okay, so that'd be 1/2. Can I reduce it to 1/2? Okay, so the slope of A is 1/2. So if B is perpendicular, what's the slope of B going to be?
2. It's just going to be 2.
-2, right? Good. All right, so then we've got the slope of B, and now C is perpendicular. So what's the slope of C? So then what do we know about A and C? Their slopes are the same, so what do we know about their relationship? They're parallel. But again, we can logically think about that. So good question. How about 7? We know angle 2 is 28 degrees, and angle 17 is 73 degrees. We also know we have all these parallel lines, right? We've got 3 parallel lines here, and then we have 2 transversals. So I get that they want you to find 4, 6, 7, 12, 16. Don't think you have to find those in order. Like when I'm solving these or thinking about these problems, I try to like just think about one set if you want to. Let's find 16. Why would you find 16? Okay, well you don't, but like I would go off of the side that like I know information on. Like first. Let me go there. So like think about some things. So okay. Well, give me a second. Like let's identify some angles that are congruent. Like what angles would be congruent? Since we know 17, what angles are congruent to 17? 19 because they're vertical. Okay, Lucas, give me another one. 9 would be. Why would 9 be congruent to 17? What's their relationship? Corresponding. Excellent. Okay, give me another one. 11. Why is 11 congruent? Those are 17 and 11 are alternate interior angles. Good. And 9 and 11 are vertical angles. And 11 and 19 are corresponding angles. Woo woo. Would 4 also be it? Why would 4 be a congruent? Alternate interior to 9, or 4 is also alternate interior to 17, right? Because they're inside, they're interior to those parallel lines. Yes. Good. And it's 4 is corresponding to 11. Okay, we did find angle 4, but give me some more. Give me another. There's one. Lucas, give me one more congruent angle to angle 17. Eight's in a different place because we're just looking, right? All we can look about is this, all the parallel lines that fall on that transversal right here. 1 is also congruent because it's vertical to 4. It's corresponding to 9. It's corresponding to 17. So all of those angles, 1, 4, 9, 11, 17, and 19 all equal how many degrees? 73. Sweet. Okay. So you could have just done, right, just the first one? Okay.
So 28.
I moved this a little bit. I'm sorry, it glitched. Okay. So then can you find the measure of angle 6 from that? No? One?
Yes.
How?
28 plus 73 minus, or no, 180 minus.
Okay, let's just say, so let's add them up. So 180 is going to equal what?
28 plus 73x, or plus x.
28 plus 73 plus x, because we said angle 1 is 73 and angle 2 is 28, and so there's our x is angle 6. So you could solve for it. Woohoo! How about the measure of angle 7?
Wait, no. I got that one. So
Y is what?
why was b minus 3 instead of normal like minus 2?
Because you had to do more work to get it. It took a few more steps than some of the others, I think.
No, it equals 101.
Yeah. Okay, so let's look. So you said it was 79? Okay. So then, let's see if we change that. So then we have 79 there for angle 6. Okay. So Lucas, now we're moving on to angle 7. What relationships can we use with angle 7 to help us? But oh, we know what 3 is. How do you know what 3 is?
It's because it's vertical to 6.
Okay, 6 is vertical to 3, so I've got so these are congruent. And then so Lucas, how do you know 8 is the same as 3? What's their relationship? Corresponding? Woo woo. So 8 is equal to 3. So how does that help you with 7? Also helps you with 16. Oh, it does help you with 16. Bam. You could answer 16. Okay. But hey, wait, I don't have a measurement for angle 3. Oh, wait, yes, I do. You said it was 79, right?
Yep.
Okay, so angle 16 is 79. Angle 8 is 79. All right.
You just take 79 minus 180.
Say that again. I don't do 79 minus 180.
I mean 180 minus 70.
All right, so we're going to do 180 minus 79,
Which is 101.
which is 101. Okay, so angle 7 is 101. Okay, and then how about angle 12?
Oh no, so angle 12 and angle 17 are supplementary, so you just have to do 180 minus 73.
Angle 12 and angle what?
17.
17 are supplementary. Okay, good.
Interiors.
Yep, these are supplementary because they're not interior. What are they? Or what kind of interior are they? Consecutive. All right, I don't know if you can see that yellow.
Yeah.
Okay, I was like, I feel like I can see it really well, but maybe not on my screen, can I? So yeah, so those are consecutive, and they would equal 180 when you add them. So you can find 12. Awesome! But you see how it's like knowing, hey, this relationship, oh, this connection, oh, that connection. Yeah, now I'm making it. Okay, good. Then let's look at 8. All right, state the postulate or theorem that justifies each conclusion. Now these I like these a lot, like because these things help us build our knowledge base more for doing proofs. Okay, so it says if angle 5 is congruent to angle 3, then A is parallel to B. All right, so what's the relationship between 5 and 3?
Alternate exterior angles.
Okay, alternate exterior. All right, so it says state the postulate or theorem that justifies this. So let's look up the alternate exterior angle theorem. And let's read it. The alternate exterior angles. It might be a postulate. I don't really know. Say that again. Read it again.
If two parallel lines are cut.
Oh, stop. It says if two parallel lines. This says if two angles are congruent. It's not the alternate exterior angles thing. No, no, don't cross it out. That is the relationship. The alternate exterior is the relationship. But remember, there's also a converse that proves like the
Basically
opposite.
same thing,
It's like the
but-
backwards.
Yeah.
Yes. So read me the converse of the alternate exteriors angle.
Two lines lines are cut by a transversal, so alternate exterior angles are congruent, then the lines are parallel.
Okay, so it says if we've got two lines are cut by a transversal. Okay, that doesn't say they're parallel though. Say it again. Pick up from there, Caden.
What?
So if two lines are cut by a transversal, which is what happened,
So
and
exterior angles are congruent.
and the alternate exterior angles are congruent. So it's saying if the alternate exterior angles are congruent, which is what we have, check, then what? Caden, what's it say?
Parallel.
Then they're parallel. Check. This is the converse of the alternate exterior angles. Theorem? Postulate? Theorem. Okay, that's what I thought, but I was like, I could be wrong. I say the wrong word every now and then. But again, it's like looking at it, like reading it for that detail, like what is happening. B is not the exact same.
No, not the, but how I screwed up.
Oh, okay. How you made a mistake. All right. So let's look at B. It says if angle 6, let me erase my other work here. Okay, so if angle 6 is congruent to angle 14. All right. So what's the relationship between 6 and 14? Corresponding. So we need to look at the corresponding angles and the converse of the corresponding and see which one proves it. It's probably one or the other.
Corresponding angles.
The corresponding angles postulate? You both agree? What's it say? Read it to me.
If two parallel lines are
Oh, it says if two parallel lines. We don't know that the lines are parallel.
Converse of the corresponding angle postulate.
Okay, read me the converse.
If two lines are cut by a transversal, so corresponding angles are congruent, then the lines are parallel.
All right, that's right. Like says if the corresponding angles are congruent, then it's parallel. So yes, this is the converse of the corresponding angles. Good. Okay, so we're starting to see like we've got a. Okay, well we're gonna look at it next. All right, so the next one. Let's do some red. If A and B, oh, this is different. This one says if A and B are parallel. So I'm going to put some parallel symbols here. Then 7 and 4 are supplementary.
Yeah.
Okay, well, what's the relationship between 7 and 4? So we've got some consecutive interior angles. All right, so we're looking at the consecutive interior angles theorem or the converse of that.
Theorem, just a normal theorem.
Oh, is that what you have here?
Mm-hmm.
Oh, I'm sorry. That would be correct. So we'll add that to it. Okay. I'll make that change. It happens. It happens. I screw up. You should check them all. Okay, so when you hand me back for it, we'll have it. Okay, so they are consecutive interior angles. So what's the consecutive interior angle theorem say? Lucas, read it for me.
It says if two parallel lines.
Stop. If what?
If two parallel.
And look, this one says if A and B are parallel. So I've got two parallel lines. Keep going. Keep going.
Are cut by a transversal, then the consecutive interior angles are supplementary.
All right. So it is. That's it. What did you just read?
Angles are supplementary.
Right. What's the name of the theorem? Sorry. The consecutive?
Interior angle theorem.
Okay, the consecutive interior angle theorem. Because it says if two lines are parallel, then the consecutive interior angles are supplementary. So breaking it down and using that. Very nice. So with that, did you have a question? Oh, I thought that was a hand. let's go back to the last page. I know this was that number 20. Let's look at number 20 and kind of build on this.
Yeah, I got +1 because of that.
Hey.
I have time to do the rest.
That's all right. Okay, so it says complete the following proof. So the first part of it is just writing the given, right? So A is parallel to B, and C is parallel to D. And what's our reason for that? It's just given. Although that shouldn't be a 2, should it? Dun dun dun. I do that a lot. Okay, so A is parallel to B. So I'm going to write that. I'm going to notate that. And C is parallel to D. I like to use my diagrams.
To make Christmas trees.
It's true. To make Christmas trees. All right. And I want to prove that 2 is congruent to 16. I'm going to go ahead and mark that. This is what I'm trying to get to. It helps me visualize. All right. So that's what I'm given, and this is my goal. So what connections can you make that are going to give us, how can you link angle 2 to angle 16 if we know that these two sets of lines are parallel? How can you link them? Like it's like a treasure map. How can you make a treasure map from angle 2 to angle 16? Angle 2 to angle 8. Okay, so what do you know about angle 2 and angle 8? All right, so you could say angle 2 is congruent, right, to angle 8 because of the alternate exterior angles theorem. Or you don't even have, I mean, I honestly don't mind if you put theorem or not. If you just know the alternate exterior angles, you could write congruent. Okay. Lucas, are you good with that? Okay. Well then, how do we link angle 8 to angle 16? They're corresponding. Okay. So angle 8 is what? Congruent to angle 16 because they're corresponding. I don't know why I wrote that whole all out there. Corresponding angles. Oh, I put congruent. Corresponding angles are congruent. All right, sweet. So now we got to 16 along our roadmap, but it says we have to prove that angle 2 is congruent to angle 16. Can we do that?
Yep.
Yeah?
So you do angle 2 is congruent to angle 16. And that's the transitive.
That's the transitive property.
See, once I heard that you said to use a treasure map type thing, it was easy for me.
That's awesome. I just need to change my vocabulary. It's a treasure map. Like, here's the map, here's the treasure. How do we get there?
Yeah, perfect.
Okay. Now, here's a question. Can we come up with a different way to get there?
Yeah, go the opposite way.
Well, we can't really, well, yeah, you could go the opposite way. I'm just talking completely different. Can we come up with a completely different way to get there?
Yeah.
Lucas, you give me a way to get there. Now that you see this way, it might be hard to see a different way. Like I took a long way around, a really long way around. 12, perfect. Okay, so you're saying angle 2 is congruent to angle 12. And why is that? What is their relationship? Alternate exterior. Okay. So alternate exterior angles are congruent. Perfect. All right. So then can you get from 12 to 16? Okay. How would you, so they're congruent. Why? Okay, so these are corresponding angles, are congruent. Okay, so then can you get from, so you went from 2 to 16, and what's the reason for that you can make that leap now?
Is that alternate transitive?
Yeah, because we said, well, hey, 2 is congruent to 12, 12 is congruent to 16, so 2 is congruent to 16. That's that transitive property. Done.
Can you do it faster? Or like just right down the middle?
To what?
Angle 2 is vertical to angle 4, angle 4 is vertical to angle 14, and angle 14 is vertical to angle 16.
We cannot. That's a good question. We can't go 2 to 4, 4 to 14, because we don't know any relationship between 4 and 14. Because they're on different,
Yeah, you do.
no, they're on different transversals. So we can't. We have to go, like I did do, like mine was really long. Like I said, I went from 2 to, when I did mine, I went from 2 to 6 because they were corresponding. And then I went 6 to 8 because they were vertical. And then I went 8 to 16 because they were corresponding. So mine was a little bit longer. But again, that's the one thing that's kind of nice about having the open-ended proofs, which seems so intimidating, is like, it's like a treasure map, and you can take a lot of different paths through the city to get there, right?
Not the ones that you want.
Yeah, but when they're already filled out, you can't take the path you want. You have to use the path that they're giving you. Yes.
So could another way be 16 to 12?
Okay, hold on. Let me start over. I'm a very visual person. So could another pay be, okay, so 16 to 12,
12 to 10,
12 to 10?
10 to 2.
Yes, because 16 to 12 would be corresponding, 12 to 10 would be vertical, and 10 to 2 would be corresponding. Yes!
You could do 16 to 14.
16 to 14? Uh-huh. 14.
14 to 12. No, you can do 14 to 9.
14 to 9 would be harder because those are supplementary.
And then you can do 9 to 12. And then you can do 12 to 10. And then you can do
Oh my gosh, that's like the longest way ever to get there. Yes, you could do that, but again, that's like the longest way ever. Okay, but like once, so does that help you understand like the proofs then? Like walking it through? Okay. If you do nothing, maybe that's the thing is every night, like just read through your postulates and your theorems that we're learning, or highlight, maybe you should go through and highlight the ones that we've used a lot. So your corresponding angles, your alternate interior, alternate exterior, consecutive, maybe the midpoint theorem would be a good one. Yes. Your bisectors, your angle bisectors. Highlight some of those that we've used a lot. Highlight the transitive property. Like this is like you get to use these resources on your tests and your quizzes. Make them your own. Highlight the ones that you're like, oh yeah, we use transitive a lot, or yeah, we use the corresponding angles a lot. Eventually, you won't need to have them highlighted. You'll have them stored in your memory. But until we get there, highlight it, write on them to help you remember. Okay, so I'm going to stop this and make sure you make all your test corrections though.